Hello, we're Madison West Rocketry and welcome to our Super Science Saturday presentation. Today we'll be showing you how to make 2 different rockets that you can build in your kitchen. But first a little bit about ourselves. We participate in 2 different rocketry competitions, the Team America Rocketry Competition and the NASA Student Launch Program, in addition to participating in outreaches like this one.
All right, so the very first rocket that we're going to be making today is a baking soda and vinegar rocket. However, before starting this activity, make sure that you get permission from a responsible adult. So for this rocket, you are going to need a water bottle or a 2-liter bottle, tape, 4 pencils or popsicle sticks, 1 tablespoon of baking soda, paper towels, vinegar, at least enough to fill 1/4 of the bottle, cork or modeling clay, newspaper or cardboard. Next, on to the construction of the rocket. For step 1, take your bottle and tape 4 pencils or popsicle sticks to the outside to act as legs that will stabilize your rocket. They should be evenly spaced around the perimeter and lined up so that they extend an equal distance past the cap of the bottle, as shown in the picture. Step 2, carefully fill the bottle 1/4 of the way with vinegar. Step 3, place a tablespoon of baking soda in the middle of a single paper towel, wrap the paper towel around it, and finally twist the ends like a candy wrapper. Step 4. For this last step, you're going to want to go outside and put down a piece of cardboard or newspaper, as it can get a little bit messy. Put your baking soda in the bottle, then quickly cork it with either the cork or modeling clay, and then place it upside down on the cardboard or newspaper. Finally, step back and watch your rocket take off.
To find out how this rocket flies, we first need to learn a little bit about acids and bases. Atoms are really tiny pieces of matter that make up everything, and acids contain many hydrogen atoms. In our case, vinegar is the acid, but other examples of acids would include lemon juice or the liquid in your stomach. On the other hand, bases contain many hydrogen atoms and many oxygen atoms. Examples of bases include baking soda, which is used in a rocket, soap, and bleach. Hydrogen atoms and oxygen atoms like to make water when put together, so when an acid and a base are combined, water is produced. This is what happens in our rocket with baking soda and vinegar. During the same reaction that produces water, a gas is created. Gases take up more space than liquids and solids, so there's not enough room in the bottle for the gas. When it escapes by pushing the cork out of the bottle, the force of that escape allows the rocket to fly upward.
Next, we will be building a straw rocket. Be sure to get permission from a responsible adult first. To build and launch a straw rocket, you will need a pencil, a straw, a pair of scissors, plenty of tape, and a printed out template. Glue might also be useful. Step 1. Cut out the body of the rocket, the large rectangle. Cut along the solid lines, not the dashed one. Then, wrap the rectangle around the pencil into a tight tube. The edge should be as close as possible to the dotted line, and the top and bottom should be flat. Step 2. Cut out the 2 fin units. Cut along the solid lines, not the dashed ones. Tape or glue the fin to the rocket, lining up the bottom edge with the bottom of the tube.
Step 3. After you tape them, bend the fins outward so that each one is at a right angle to the one next to it. When you look at the bottom of the rocket, the fins should form a plus sign. Step 4. Pinch and twist the top of the rocket body around the tip of the pencil to make a nose cone for your rocket. Next, tape the nose cone so that it's airtight and to keep it from untwisting. Step 5. Now you're ready for launch. Remove the rocket from the pencil and slide it onto the end of the straw. Blow into the straw and watch your rocket fly away.
So, why do we tell you to make sure there aren't any holes or gaps when constructing your straw rocket, especially in the nose cone? These rockets are pneumatic, meaning they are launched using air pressure. Blowing through the straw allows for air to shoot into the rocket and push it forward. But if there are holes and gaps, air will escape out the sides instead of pushing it, and therefore the rocket won't fly. Have you ever wondered what the fins on the rocket are for? Think about the wings you fold when making a paper airplane, or even the tiny feathers on arrows. Why do we make those? To keep the object traveling in a straight path. Without its fins, the rocket would wobble around, flying in circles or all over the place. That's why, to ensure your rocket's success while flying, you should carefully fold the wings and keep it on its path. We applied the same process to our bigger rockets, like the ones made by our TARC and SLI teams, to make sure they fly straight.
The rockets that launch into space are made up of 4 major systems based on function. The structural system holds the rocket together, and the propulsion system includes the rocket engine and fuel. The payload system consists of anything a rocket is carrying into space, like a spacecraft, satellite, or even a human being. Lastly, the guidance system is made up of radars and computers. When a rocket flies, there are three forces acting on it: thrust, drag, and gravity. Thrust is the force that pushes the rocket upwards. In the case of the straw rockets we just built, that's the air you're blowing into the straws. Propellers, jet engines, rocket engines, that's how we get thrust. Drag slows down the rocket. Thrust is trying to move you forward, and drag is trying to push you back. This is generated by air in a rocket, because when the rocket flies, it has to push air molecules out of the way. This is called air resistance. Making the nose cone a cone shape helps to decrease the air resistance. Also, parachutes use that drag to slow down, so they can have a nice soft landing. Gravity is the force that the rocket needs to overcome if it wants to take a flight. If I have this apple here and let it go, it's going to fall down to the floor because of gravity. The Earth wants to pull this apple right into its center. And there you have it, the three forces of rocket flights and how they relate to space travel. So this is the end of our presentation, and I hope you guys enjoyed it. If you'd like to watch this video again to follow through with the rocket instructions, it is available on our Madison West Rocketry YouTube channel. Also check out our website, westrocketry.com, for the straw rocket template and more information. Thank you for being part of the virtual Super Science Saturday with Madison West Rocketry.